Are you struggling to use pre-trained word embeddings in your Keras model? You're not alone. Today, we're diving into how to effectively retrieve embedding vectors from character strings using Google's LM1B embeddings. I totally get it. It can be really confusing when the documentation doesn't clearly explain how to use these embeddings. Many users have faced similar challenges, especially when trying to integrate them into their models. Here's the specific question we're addressing. One user asked how to retrieve an embedding vector from a given string of characters using the pre-trained embeddings provided by Google. They found the syntax for feeding in pre-trained embeddings, but converting the files to the required format was unclear. Sound familiar? Let's explore this together. So what's the issue here? The challenge lies in understanding how to convert the different files and their structures into the pre-trained matrix needed for the Keras embedding layer. Plus, figuring out which softmax output to use can be tricky. And stick around. By the end of this video, you'll have a clear understanding of how to implement these embeddings in your Keras model, plus a bonus tip that will make your NLP tasks even easier. To begin using the pre-trained word embeddings in Keras, the user first needs to load the embeddings from the provided files. This can be done by reading the embedding file and converting it into a matrix format. Next, the user should create a matrix that aligns with the vocabulary of their dataset. This involves initializing a matrix where each row corresponds to a word in the vocabulary and populating it with the pre-trained embeddings. After creating the embedding matrix, the user can now set up the Keras embedding layer. This layer will use the embedding matrix as weights, allowing the model to leverage the pre-trained embeddings during training. Finally, the user can integrate this embedding layer into their Keras model. This allows them to add further layers for other NLP tasks, such as LSTM or dense layers, to build a complete model. Fun fact. Did you know that word embeddings can capture semantic relationships? For example, the vector for king minus man plus woman results in a vector very close to queen. How cool is that? Now let's look at the answers provided by other users. This user explains that the Keras embedding layer requires integer indices for input words rather than the strings themselves. To use pre-trained embeddings, you first need to convert your input words into a sequence of indices that match the vocabulary used in the original model. That's the end of that answer. Let's see another perspective. An alternative approach suggested by a user involves using Count Vectorizer or TFEDF Vectorizer for text encoding in NLP applications. Count Vectorizer is suitable for simple tasks like spam detection, while TFEDF Vectorizer provides insights into the relevance of terms based on their frequency across documents. Here's that bonus tip I promised. Always pre-process your text data consistently. This means tokenizing and normalizing your input before feeding into the model. It can save you a lot of headaches down the line. And there you have it. You should now be able to use pre-trained word embeddings in your Keras model with confidence. If you found this video helpful, please subscribe for more tips and tricks on NLP and machine learning.